As we work through the last day of chapter 9, you're going to get a strong feeling of deja vu where you're like, we've done this before, haven't we? And the answer is yes, you did it in chapter 6 of Pre-Calculus 20. What we are doing is we're solving a rational equation. You've seen this before. I know I've jumped right over number 1 in the notes, but it's something that, again, should be ringing a bell. What we're going to do to solve this using an algebraic technique is we're going to get a common denominator, then we're going to drop it and solve it. And so here, let me just dive right into the work, and then we'll kind of explain what is going on along the way. What we are doing is we're trying to say what value of x would satisfy this equation, where you could plop it in, and then the left side is equal to the right side. So our technique was to scan the denominators and say the common denominator is x plus 2. So we will have to times top and bottom by x plus 2 on the right side. The left side needs nothing, it already has it. And then this was our technique. Once you have a common denominator, we just dropped it because it had no more impact in the answer. It didn't change anything. There's an equality, so you can do that. We've done that many times in this course alone. And then here's what we're going to do. We're not quite ready to swoopy swoop because this is not equal to 0. We will FOIL this out. And if we FOIL it out, we would get I'm sorry I'm not doing it in order, a negative x squared, a 3x, and a 10. And now we are ready to do our common theme in high-end math. Let's bring everything to one side. I'm actually going to bring everything over to the left because I really like it when our x squared is positive. It will become a positive x squared, a minus 3x, and then a minus 4. And now we have it equal to 0, and I have it written in the order that we want it in. We know now to factor this guy, and we factored into x minus 4 and x plus 1. We swoopy swoop. We've got x equal to 4, and we've got x equal to negative 1. And here's where the real explanations come in. We have done this before. This exact question could have been in Pre-Calculus 20, and it's the exact level that we've been doing. So first of all, why? Why would we do this? Well, now is when you're truly supposed to understand what just happened. So what I'm going to do is just take away part of the work. You don't have to do that if you're recopying the notes. Now, unlike before in our previous course, you should have a full understanding of what did we just do. Before we were just saying, hey, I did it, some kind of magic, or you do a little drum roll and say, there's our answer, but now we get it. If we were going to look at it graphically, you have 6 over x plus 2, that would be a graph that has an asymptote at negative 2, horizontal at 0, and then if you do the old, the y-intercept is 3, this is a pretty good representation, better than maybe what's in the PDF notes. That would be if you were just saying, what does the graph of y equals 6 over x plus 2 look like? That is your classic asymptote graph. Now let's cover this up. Let's say you just looked at the 5 minus x, and just say, again, you had y, or f of x equals 5 minus x. That is just a line. That's a line that has a y-intercept of 5, a negative 1 slope, so that line would just go somehow like this. Now here is where you might realize why you're doing this again. Now is when you truly get it. When we solve this guy, what you're really doing is you're finding a point of intersection. That's really what you're doing. And so right here, the point of intersection, and sorry I'm not going to finish it all the way, could easily be a 4. And so if you put in a 4 on this side, well, imagine it. Put 4 here, 4 plus 2 is 6. 6 divided by 6 is a 1. Put a 4 there, you got a 1. It's right, it works. Well, that's our point of intersection. Now here's where, we won't finish it because we got one more to look at. We've seen this before. Sometimes you take a number and you put it in and it works, and then sometimes it doesn't, and you're like left wondering, well, what just happened and why didn't that work? And so here would be an example of it. You take negative 1, you put negative 1 on this side, and you get an answer of 6. You put negative 1 in on this side, you got a 6, so it still worked, but let's say it didn't. Okay? What really it's saying is that if this did not work, remember when it was called an extraneous root, it really means that the two graphs did not intersect at that point. If they both work, if they're both good, well then there was 2 points of intersection. If only one worked, that means there was no points, that point was not a point of intersection. And so this is why you're doing it again, because now you're supposed to have a full understanding. So let's go to our final example. And it's a neat way to finish. In our final example, letter B, it gives us x squared minus 3x minus 7 divided by 3 minus 2x, and then we just have a simple equals x minus a 1. So this guy, don't start factoring right away. What we will do is we'll say, okay, we need first of all a common denominator. You scan the denominators, and the common denominator is 3 minus 2x. So we will times top and bottom on the right side again, and it's not always the right side, by 3 minus 2x. And then here's what we can do. Once we have a common denominator, we can just drop it in the equality. We've done that with logarithms, with exponential equations. And what we will need to do is we will need to prep this. We're going to have to FOIL out this side. And if we FOIL out this side, I'm going to jump the gun and get right down to the simplified version. I trust everyone can FOIL at this level. And then we have an x squared, a minus 3x, and a minus 7. We will bring everything to one side. I still like to have the x squared positive, so I'm going to bring everything over to the left side. We will let it equal 0. Now, you have the notes in front of you. You can see how we finished. Sometimes you have to use the quadratic formula. And so that's no big surprise. It never goes away.